All right. Um, we're just going to go ahead and get started on this. As usual, I'm just going to go through this practice exam as slowly and as methodically as I can. And as I do that, you guys can ask questions along the way. Keep in mind, there is like an 8 to 10 second delay on my part. So if you ask a question, it might be a couple seconds before I actually answer it. All right. Um, this exam is cumulative. All right, so everything from order of operations, everything from the first review test, so equations of lines, solving equations, evaluating order of operations, all the way to parallel lines with transversals and using proofs. Um, things to keep in mind, there are a couple of things that you just kind of have to memorize. So, names of polygons, certain definitions like regular polygon, equilateral, equiangular, um, vertical angles, linear pair, all those names that you would use for a proof are all fair game. All right. Um, so with that in mind, I'm just gonna start, and again, as I go, ask questions, and I'll keep an eye out. So these first two just have to do with evaluating an expression, and it's mainly order of operations and adding fractions. So number one is a little bit longer. I'm just gonna simplify step by step, and again, ask if you have a question. So first order is parentheses, and I'm going to simplify just a little bit more with that. Um, the next order is exponents. So that's 6 squared becomes 36. And then we can simplify this top part. So when you simplify this down, um, in this second step, we get 3 plus 72 minus 8. That becomes 67. Everything else stays the same. And then we can multiply the numerators. So when we're multiplying fractions, you multiply the numerators and you multiply the denominators. So 5 times 67 times 3 is 1005. And then 1 times 2 times 5 is 10. On number 2, we are adding fractions. And in order to add fractions, you have to get a common denominator. Um, so the easiest thing to remember here is to just multiply by the other denominator over itself. When you do that, 9 times 13 is 117. 9 times 7 is 63. 4 times 7 is 28. And again, 63. And then once we have the denominators the same, then we can just add the numerators. So 117 plus 28 is 145. And then that's your answer. You don't have to simplify or anything. I just want that. The proofs won't be super difficult. Um, I think both of them are like 3 or 4 step proofs. And really just each of them has to do with like, do you recognize that something is a vertical angle or a linear pair? Um, or like add up to a different angle. They shouldn't be too hard. All right. Moving on to number 3 and 4. Um, Solving equations with variables on both sides. The first thing you should always do is just simplify each side. So this 5 will distribute. So we get negative 15 plus 30r. So once you distribute, you get negative 15 plus 30r is equal to negative 15 plus 3r. I'm going to get all the constants on the right-hand side and all the variables on the left-hand side. So I'm going to subtract 3r from both sides. To get negative 15 plus 27r is equal to negative 15. Then we add 15 to both sides. So we get 27r is equal to 0. So then r is equal to 0. Same thing on number 4. That negative 3 distributes to both ends. So we get negative 12 plus 9x is equal to 3x minus 36. And then I'm going to get all the variables on the left-hand side and all the constants on the right. So we subtract 3x from both sides to get 6x. Add 12 to both sides. And then divide by 6. Number 5 and 6 have to do with equations of lines. So we need to know 2 basic formulas. Y equals mx plus b, and y minus y1 is equal to m times x minus x1, where m is the difference in y's over the difference in x's. Your test looks exactly like this. I literally hit regenerate and then made sure everything works. So using those 2 formulas, we can get equations of both number 5 and number 6. All right. So on number 5, because we see a y-intercept, which is this point right here, and we can get a slope, I would use slope-intercept form. All right, so in this case, b is where it crosses the y-axis. So b is equal to 1. And then our slope is up 1, 2, 3, and then over 5. So m in this case is 3/5. So because b is 1 and m is equal to 3/5, our equation will be y is equal to 3/5 x plus 1. On number 6, we do basically the same thing. So first thing we have to do is to find the slope. I'm going to label this x1, y1, and this x2, y2. And then we just plug it into our slope formula. So m will equal y2 minus y1 over 1 minus 0, which simplifies to negative 5 over 1, which is just negative 5. Then we have a slope and 2 points, which we can just plug into point slope form. All right, so we already have an x1 and a y1 labeled, and we have m. So our equation will be y minus 4 is equal to negative 5 x minus 0. This is an equation. You don't have to go any further than this. You can just leave it like that. So you don't need to simplify it or anything. You don't need to get to slope-intercept form. You just need an equation of a line. So before we go further, are there any questions over the first 6, the first page? It does not matter what equation you put it in. It could be point slope, which is the one boxed, or slope intercept, like the one in blue. It doesn't matter, whatever you're more comfortable with. That's fine. I didn't specify what kind of equation of a line, so whichever one is up to you. At some point, you're going to have to show some amount of work. Like finding the slope on number 6, you got to show me that. And then plugging it in really is the work. The problem is, if you don't show work and you get a question wrong, I can't give you any credit. So if I were you, I would show as much work as I can. It doesn't have to be like a crazy amount, but the more work you show, the more chances I have to give you partial credit. All right, I'm going to say 2 quick things about numbers 7 and 8. I can't do either of these because it's on a computer and the image gets distorted. You will have your own protractor for the exam. You are not giving me decimals. So if you give me an answer that looks like 4.75 or something, that's going to be wrong. Okay. I'll give you some credit if you're close, or if you're right on, you just didn't give me the fraction. Every one of those small little notches inside of an inch, those are 1/16. All right. So if you have 1 inch and then 5/16, this is your answer. Okay. You don't give me a decimal. You give me basically a proper fraction. That's what I'm looking for. For number 8, keep in mind that there are degree measures in both directions on a protractor. All right. So if a degree is greater than 90, you're going to take the bigger measure. All right. So on a protractor, if our line is this, that is greater than 90 degrees. So we're taking the larger of the two numbers over here. Okay. If it's smaller than 90 degrees, we're taking the smaller of the two. So if it's greater than a right angle, you're taking the bigger. If it's smaller than a right angle, you're taking the smaller. So are there questions about that? I know I can't really do this on the computer, but I'll try and answer any questions I can. All right. Number 9 and 10. Number 9 and 10 rely on the segment addition postulate and the angle addition postulate. All right. So this blue line, this bottom line, gives you the whole measure. All right. So 2x plus 32 is going to be equal to the sum of these two parts. So 2x plus 32, the entire thing is going to be equal to 4 plus x plus 17. So the first thing you do is to simplify both sides, and then we're trying to get x by itself. So I'm going to subtract x from both sides, and then subtract 32 from both sides. And then negative 11 is your answer. On number 10, you have to be a little bit careful. This is where being able to identify certain angles comes in handy. All right, so ZBA, that's 100 degrees. CBA, the entire angle is 9x plus 22. And then CBZ is 3x minus 6. Okay, so the giant angle is going to be equal to the sum of its two parts. So 9x plus 22 is going to equal 3x minus 6 plus 100. And then we have to solve for x. So if we simplify the right-hand side, we get 3x plus 94. I'm going to get all the x's on the left, all the constants on the right. So if we subtract 3x from both sides, we get 6x plus 22 is equal to 94. Subtract 22 from both sides. And then divide by 6. Questions about number 9 or 10? Alex, I will as soon as we get there. All right, number 11, 12, 13, and 14. Those all rely on your knowing different definitions. All right, so an acute angle is something that's less than 90 degrees, and we have to draw that. Okay. Because you're given a protractor, I expect these to be accurate. All right, so if you draw me something around 90 degrees that looks like it'd go either way, I'm going to mark it wrong. All right. I would also like these along a straight edge so I can actually tell it's an angle. All right, but you have to then label it. All right, so B will be your vertex, and then C and A will be on the other two sides. A straight angle is just a straight line. R will be the vertex, so it'll be the center point. And then T and V will be on either side. A regular polygon is a polygon that is convex, equilateral, and equiangular. All right, so the easiest example of this is just a square. And again, because you have protractors and are able to measure this, I expect it to be accurate. On the test that we did this, a lot of people drew something that looked like this and called it a square. I'm going to mark that wrong. Number 14, draw an equilateral polygon that is not regular. An equilateral polygon is a polygon whose sides are all congruent. Okay, but we don't want it to be regular, so it can't be equiangular. So it cannot be a square. All right, a parallelogram is a perfect example of it. Where each of these sides are congruent. But not all of the angles are congruent, which makes it equilateral and not regular. Questions on 11 to 14. All right. Number 15, distance between each pair of points. Yes. Yes, you have to put 3 points when you draw an angle because that's how you identify angles. All right. Distance formula is the square root of the difference in x's squared plus the difference in the y's squared. All right. The best way to do this is to just memorize it. That's as easy as it gets. You just got to memorize the formula and then plug stuff in and simplify. All right. On this question, though, you have to find these 2 points as well. All right. So this is -1, -5. And this point is 4, 2. All right, so 4, 2 can be our x1, y1. -1, -5 can be our x2, y2. And then we just plug in. All right, so d is equal to the square root of x2, which is -1, minus x1, which is 4, squared, plus y2, -5, minus y1, which is 2. And then you have to simplify. So you follow order of operations here. So you simplify inside the parentheses first, and then worry about everything else. So -1 minus 4 is -5. Negative 5 minus 2 is negative 7. Negative 5 squared is 25. Negative 7 squared is 49. That gets us 74. And then that's as simple as I can get. All right. If it is something that you can simplify, I would expect you to simplify as much as you can the radical. As of right now, if you don't know how to do that, I would just leave it as that. This is as simple as it could get, but if on the test you can't actually simplify it, but you don't know how, just leave it. We're getting there, Devin. Okay, number 16, midpoints. A midpoint is just the average in the x's over the average, and the average in the y's. So midpoint of any 2 points is the average in x's and the average in y's. All right, so again, the first thing you have to do is to get these points. So this is negative 5, comma 2. And this is 0, comma 5. All right, so negative 5, 2 can be our x1, y1. 0, 5 can be our x2, y2. And then we just plug it in. So x1 plus x2, y1 plus y2. And then just simplify. You don't have to make it a decimal. Just simplify the numerator. So negative 5 plus 0 is just negative 5. So we're left with negative 5 over 2. 2 plus 5 is 7. So we have 7 halves. That's your answer. Just leave it like that. So again, midpoint is the average in the x values and the average in the y values. You add up the two x's, divide by 2. You add up the two y's, you divide by 2. Number 17, 18, 19, 20. You state if each polygon is concave or convex, and you label the name of the polygon. Okay, so you need to know which sides give you what name. First thing that we're going to do is to decide whether or not each of these are concave or convex. All right. Number 17, if we extend each of the segments, none of them should go through the interior if it's convex. These do, so this is concave. Number 18, again, if you extend each of these segments, if none of them go on the interior, then it's convex. After you do that, you count the sides and then give it a name. All right, so 17 has 1, 2, 3, 4, 5, 6. So this is a concave hexagon. Number 18 has 1, 2, 7. So this is a convex seven-gon. If you know the name for a seven-gon, go for it. I'm not expecting you to know it though, so it's just a seven-gon. But while we're here, remember that you need to know the names of 3, 4, 5, 6, 8, and 10 gons, where 3 are triangles, 4 are quadrilaterals, 5 are pentagons, 6 are hexagons, 8 are octagons, and 10 are decagons. Everything else is the number of sides dash gon. Okay, so an 11-sided polygon isn't just an 11-gon. A 20-sided polygon is just a 20-gon, all right? '21 and 22, again, this is mainly just addition postulate and then knowing what linear pairs look like in right angles and vertical angles. So 21, this entire angle is 90 degrees. So 5x plus 1 plus 3x plus 9 is equal to 90. Combine like terms, so you get 8x plus 10 is equal to 90. Subtract 10 from both sides, and then divide by 8. So you have to know what a right angle looks like, and you have to know that you have to add those two things together. Okay, number 22. These two angles form a linear pair. Therefore, they add up to 180. All right, so 6x plus 5 plus 37 is equal to 180. So x will equal 23. Area, circumference, and diameter. The area of a circle is pi r squared. The circumference is 2 pi r. And the diameter is just 2r. All right, so the area of this is pi times the radius squared. .9 is 79.21. So our answer is 79.21 pi. Circumference is 2 times pi times the radius, which equals 2 times pi which equals 17.8 pi. And again, when you guys answer these, I want these as multiples of pi. So if you do 79.21 times pi, you get 248.8455, whatever. That's not the answer I want. I want 79.21 pi. No one ever simplifies pi. And then the diameter is just 2 times the radius, which is just 17.8. There should be units of measure on this, so all of these should have kilometers or kilometers squared at the end. I'm just worried if you know the actual formulas. All right, and everything on this page is just, do you know formulas of area? So I'm just going to write this on the side real quick. Areas of quadrilaterals. It's just base times height. Areas of triangles. A is equal to 1/2 base times height. All right, so knowing those is very important because if you do one of them, that might not be right. All right, so number 24, this is a quadrilateral. This is a square. So our area is just 7 times 7, which is equal to 49 yards squared. 25 is the same way. So area is 4 times 10.9. Which is 43.6 centimeters squared. Number 26 is 6.4 times 3.1. So that is 19.84 yards squared. Again, I'm not too worried about units of measurement. I'm just worried about if you know the equation or not. 27, that is a triangle, so our equation is 1/2 base times height, which is 1/2 2.8 times 4. Which is 5.6 feet squared. Questions about any of the area problems? 28, 29, and 30. Really, the rest of this test has to do with chapter 3, which is what we just covered. Chapters 2 and 3. Um, 28, you have to know that these two are alternate interior angles. I don't require you to say that, but you have to know that's what they are. All right. So you have to also know that alternate interior angles are congruent to one another if these two lines are parallel, which they are. Yes, tomorrow is dress Sunday. So 4 plus 19x will equal 80. 19x equals 76. Divide both sides by 19, so we get x is equal to 4. Number 29, these are consecutive interior angles, so they add up to 180. Combine like terms, so x plus 188 is equal to 180. Subtract 188 from both sides, so x is equal to negative 8. 30 is the same way. Those are consecutive interior angles, so they add up to 180. So then x is equal to 7. All right, 31. Given the following conditional statement, give the following the converse, the inverse, which is spelled wrong, and the contrapositive. Then state if each statement is true or false. So there are two things you have to do. Find the converse, inverse, and contrapositive, and then state whether or not they are true or false. Okay, so our original statement is if you bought a house, then you spent a lot of money. So our converse well, first of all, this statement would normally be true. Houses are expensive, so they usually take a bit of money. All right. Converse of that is if you spent a lot of money, then you bought a house. All right. This would be false. You can spend a lot of money and not buy a house. All right. You can buy a car. You can buy a lot of things. It doesn't necessarily have to be a house. The inverse is if you did not buy a house, then you did not spend a lot of money. Again, this is false. Just because you didn't buy a house doesn't mean you didn't spend a lot of money. And the contrapositive is if you did not spend a lot of money, then you did not buy a house. And that would be true. Okay, you know you did this right if these two statements are the same and then the contrapositive matches the original. So, Brady, the reason the inverse is false is because I can give you a counterexample. So that statement says if you did not buy a house, then you did not spend a lot of money. What if I bought a car? All right, I didn't buy a house, but I did spend a lot of money. What if I enrolled to a master's program? All right, I did not buy a house, but I did spend a lot of money. There will not be a truth table. So basically, for every one of these statements, if you can find a counterexample to them, then they're false. Questions about 31. I really hope so. Because if there's not, then we have to come in on Friday. All right. Now the proofs. Yes. So yeah, if you can't find a counterexample, then it's true. Now that requires thought. Like if you can't find a counterexample, that doesn't necessarily make it entirely true. Um, if I find a counterexample to it, and it should be decently obvious, then it's gonna be false. I'm not gonna ask about biconditional, but uh, both the original and the converse have to be true for a biconditional statement. Okay. Number 32. The first thing I'm going to do is to label some of these angles. So the way I would go about doing this is saying that angle A and angle C are a linear pair. Because given, right, you can assume things are a linear pair from a diagram. So we know that A and C are a linear pair because they form a straight line. The next step would be angle A plus angle C equal 180 because of the definition of linear pair. You could also just kind of skip this step and just go straight to 100 plus the measure of angle C is equal to 180. Therefore, the measure of angle C is 80 degrees. That can all be one step. That's fine. But I guess you would add in substitution and simplification. But I'm all right with just having that be one step. Okay, then because the measure of angle C because angle C and E are corresponding and they're congruent, that means that M is parallel to N. Okay, so angle C is congruent to angle E. Therefore, M is parallel to N because the corresponding angles are congruent. Questions about that proof? Yeah, you can come in early. Brady, you could, but your proof would be a little bit longer. So angle C would be 100. This angle would be 80. Therefore, they add up to 180. So then they're parallel. So again, there's different ways to do this. I'm just trying to choose the most direct route so you guys can see it and not be totally overwhelmed by it. All right. And then the last proof, given NOP is congruent to NPO and ROP is congruent to RPO, prove that NOR, which I will label in blue, NOR is congruent to NPR. All right, so step one is just repeat what's given. And then work on solving this. All right, so we're given that NOP, the big angle, is congruent to NPO, the other big angle, and ROP, the smaller angle, is congruent to RPO with the other smaller angle. All right, so the only part we're missing are the smaller ones. So we can set up a sum of two angles equal to a bigger one. All right, so angle NOP is equal to NOR this top angle plus ROP the bottom angle. And we can do that because of angle addition. And then we can do the same thing for the right hand side. So NPO is equal to NPR plus RPO. And that's the same reason. Then we can do some substitution. So I'm going to substitute well, first we can set these things equal together because NOP is equal to NPO. All right, so we can set NOR plus ROP equal to NPR plus RPO. And we're trying to prove that these things are equal. So in some way we have to get rid of ROP and RPO, but we know they're equal to one another because of this given part right here. Okay, so we can substitute one more time. And then because RPO is on both sides, then we can simplify. And then we have what we're trying to prove. Questions about that proof? I believe the one I put on the exam is actually slightly easier than this. I don't think it's necessarily 5 steps, but I would think that this is doable. One proof will have to do with stuff that we covered in chapter 3. The other proof will be kind of like what was on the last test and this one. It'll involve not just transversals and parallel lines. So one will involve that, one will not. Okay. Are there any questions on anything on this practice test? Uh, Again, I hope we have school tomorrow because if we don't, then we have school on Friday. I think the chances are pretty high for a late start. Um, but we're already starting at 9, so I really don't even think that'll be a problem. Unless it's worse than what people are saying. All right. Any questions about the practice exam? Or questions about, I don't know, geometry and not whether or not we're going to have school tomorrow? All right. Since there are no other questions, I'm going to leave this open for the next 5 or so minutes. And if there's no questions for us after that, then I'll shut it down. Yes, we can go over midpoint. All of them. Thank you, Switzer. All right, midpoint. Midpoint is the average in the x values and the average in the y values. So all you do is plug it into this formula. There's really nothing more to it than that. You're trying to find the middle point on this line, which is the middle in the x and the middle in the y, right? So 4 plus -3 over 2 and 3 plus -2 over 2. So we get 1/2 and 1/2. And this is our answer. I'd rather not regenerate another one just because it's so long. Um, I don't want to do every single problem. If you have a question on a specific problem, I can help you though. All right, I'm gonna call this. If you have questions, you can come in early. I'll probably be there at least a half an hour early, provided we don't have any crazy extra weather. So I'll definitely be there by 8:30, weather permitting. If not, just a little bit earlier. So you're welcome to come in, ask questions. Otherwise, I'm getting off. So thank you.